Hello everybody, we are Vincent and Fai, and we are working on the smart clothing using LEDs or other devices as our FYP final year project. And this is a presentation about our process in our fall semester and summer semester. As we mentioned that we are doing the smart clothing using LEDs, so we have set up the final scoped prototypes for our smart clothing, which is a smart jacket. This is the outside design for our jacket, which consists of a back LED display and some LEDs here and some short buttons and another LEDs display here. And this is the inside design of our LEDs of our smart jacket, and the microcontroller, the battery and the Bluetooth device is hidden here. And these are three functions. These three functions of our jackets. The first function is show our image or some tests on the back LEDs displayed on the jacket, which is sent and controlled by the smartphone. And the second function is we can call phones or receive phones using this jacket. With the smaller LED displayed, there is numbers showing which phone numbers dialing or you are dialing, and we can dial phones using the dial soft button. We can answer and receive phones using the speakers and mic. And this is the phone function, second function, phone function. And the first function is showing some light patterns on the LEDs here on the arms to increase the sense of fashion sense for our jacket. And this is the final goal structures of our smart clothing, smart jackets. It consists of processors inside the clothing, which is communicated to the Bluetooth and to the smart code and controlled mainly by the smartphone. And these some input or output devices, for example, the microphones, the speakers, the LED display, and some dial soft buttons or on-off soft button. These are three layers. There's three areas for us to finish this FYP. The first area is to handle with the e-test tool. The second is to handle wireless communication. The first is to develop a smartphone app. And in the summer and fall semester, we mainly focus on the first two areas, which is handling with e-test tool and handling the wireless communication. These are three projects or some experiments we done in our summer and fall semester. The first one, the wrist accessory, is done in the summer semester. And this is the demo of our smart product. This is a LED which controlled when a magnet is approached to turn it on or turn it off. And this is the schematics of our switch accessories, which is have an input of the wrist switch, and also which is control. There is a flip-flop that continues to signal when there is some input change, signal change. And this is the second project for our FYP is the piano tie. The second and the third project is done in the fall semester. And this is the demo of our real piano tie. This is the real image of our piano tie. And when we push the button, we can play piano on the tie, and we can actually wear the tie. And this is the inside structure of our piano tie, which is controlled by a linear pad, and we input the signal by using some soft buttons and make up of conductive fibers. And this is the schematics of our piano ties. And we learned 3 things in this piano ties. 3 important things. The first thing is the soft buttons, which is an improved versions of buttons better than the wrist switch, because it is soft and flexible, which can included or embedded in the smart clothing or smart jacket easily. So and without the strange shape on the edge of the hard components. So this is a good way for buttons for smart clothing. The principle of the soft button is there is 2 conductive fibers, and in between there is normal fibers to separate 2 conductive fibers. If we want to send a signal, we need to push the upper conductive fibers and through the hole and connect to the lower conductive fibers to send a signal out. And the second thing we learned is the use of microcontroller. There's a lot of microcontroller we consider using during our project. For example, the linear pad, the Arduino Uno, or the STM32, and we finally choose the linear pad for this project because the linear pad is very fat and can be sealed firmly by the conductive thread. And there's some pros and cons for this microcontroller because it is flat and can easily hide it or embed it in the smart clothing. So this is advantage, but the linear pad only have 20 input or output pins. That's limited, and we cannot do the LED displays using such small amounts of input or output pins. So finally, we decided to develop our own microcontroller, which is fat and consists a lot of input or output pin instead. And the third thing we learned is how to use of others e-textile. For example, the conductive thread. Shielding this conductive thread is quite difficult, and it can be shielded by the shielding machine, but we need to measure the length of the conductive thread because there is a height resistance on the conductive thread. Also, the conductive thread can be easily sorted, and the short circuit can be easily short circuit because if we not firm it very firmly, it can be easily loose. And this is a project that we learned about the e-textile. And the last project is a 3x3 LEDs matrix controlled by the Bluetooth. And this is the demo. This is the LED display. When we input some buttons on the on the keyboard of our computers, the the light will light up. And we also input some patterns on the 3.3 LED matrix. And this is a project that we learned about the wireless communications. We use the Bluetooth-made silvers to communicate between the microcontrollers and the computers, and can control the LED matrix. Also, the second thing we learned from this project is the principles of LED matrix. This is very essential for us to build our LED display. To sum up, there is 3 important knowledge we have learned through in this summer or fall semester. The first thing is to handle our e-test properly, especially using soft buttons, because there is a lot of variations in the shielding or some the principles of actually how to paste the e-test style. So we learned a lot on this topic in this semester. And the second thing is the working principles of the LED matrix that can help us to improve the LED displays of our smart jacket. And the third is the wireless communication between the processor and the computers or the smartphone. And there is 3 improvements that we need to do after these presentations. The first thing is to start developing the iOS apps, which is the third area we need to do in our project. And the second is, as we are a bit out of schedule, we need to start building the smart jacket immediately to submit the project in time, finally. No, okay. And the third thing is we need to develop another microprocessor which is fully suitable for our smart jacket for our own use. And this is the presentations we want to make. And if there is any suggestions and improvement, feel free to talk to us. Thank you.